When adding a second 200 amp panel in a residential setting, you typically do not need two separate meters. The existing meter is usually sufficient to measure the total electricity consumption of both panels. Regarding grounding, you can generally use the existing ground rods for both panels. However, it is crucial to bond the ground rods together to ensure proper electrical grounding. To bond the ground rods, connect a solid copper wire between them. The wire should be at least 8 feet in length and have a diameter of at least 6 American wire gauge. The additional 200 amp panel will most likely be a subpanel connected to the main electrical panel. The main breaker in the main electrical panel will need to be sized appropriately to accommodate the increased electrical load from the subpanel. It is important to consider the total load on the main panel and ensure that the main breaker can handle it without tripping. The wiring between the main panel and the subpanel must be sized adequately for the anticipated electrical load. Use the appropriate wire gauge to handle the current. Consult the National Electrical Code, or NEC, for the correct wire size based on the amperage and distance. In most jurisdictions, adding an additional electrical panel requires a building permit. Contact the local building department to obtain the necessary permits and ensure compliance with electrical codes. When calculating the load for the new subpanel, consider all the appliances and devices that will be connected to it. Use the nameplate ratings of these devices to determine their power consumption in watts or amps. Add up the wattage or amperage of all the devices to get the total load. For continuous loads, which are loads that operate for 3 hours or more at a time, multiply the load by 1.25 to account for the increased demand. This is required by the NEC. Size the subpanel breaker based on the total calculated load. Choose a breaker that is rated for at least the calculated load, but not larger than the ampacity of the wires feeding the subpanel. When running the wiring between the main panel and the subpanel, use the correct type of cable or conductors for the application. Non-metallic sheathed cable, such as Romex, is commonly used for interior wiring. For exterior wiring or wiring in damp locations, use a waterproof cable or conduit. Ensure that all wiring connections are made properly and securely. Use wire connectors, such as wire nuts or crimp connectors, to join the wires together. Make sure the connectors are rated for the wire size and application. When grounding the subpanel, connect the ground wire from the subpanel to the grounding electrode system. This can be done by connecting the ground wire to the ground busbar in the main panel. The ground busbar is connected to the ground rods. Make sure all metal enclosures, such as the subpanel enclosure, are properly grounded. This helps to prevent electrical shock. Use grounding screws or bonding jumpers to connect the metal enclosures to the grounding system. When installing the subpanel, follow the manufacturer's instructions carefully. Pay attention to the torque specifications for all connections. Over-tightening or under-tightening connections can lead to problems. Once the subpanel is installed, test it to make sure it is working properly. Use a multimeter to check the voltage and current at various points in the subpanel. Verify that the breakers are tripping properly when overloaded. Be aware of arc fault circuit interrupters, or RFCIs, and ground fault circuit interrupters, or GFCIs. RFCIs are designed to protect against arc faults, which can cause fires. GFCIs are designed to protect against ground faults, which can cause electrical shock. Install RFCIs and GFCIs in accordance with the NEC. Arc fault protection is typically required in bedrooms, living rooms, and other areas where people are likely to be present. Ground fault protection is typically required in bathrooms, kitchens, and other areas where there is a risk of water exposure. Make sure the subpanel is properly labeled. Label each breaker with the circuit it controls. This will make it easier to identify and troubleshoot problems in the future. Keep the subpanel clean and free of debris. Dust and dirt can accumulate inside the subpanel and cause problems. Periodically inspect the subpanel for any signs of damage or wear. Replace any damaged components immediately. If you are not comfortable working with electricity, hire a qualified electrician to install the subpanel. Electricity can be dangerous, and it is important to take precautions to avoid electrical shock. Always turn off the power before working on any electrical equipment. Use insulated tools and wear rubber gloves. If you are not sure what you are doing, consult a qualified electrician. When selecting a location for the subpanel, choose a location that is easily accessible and has adequate ventilation. Avoid installing the subpanel in damp or humid locations. The subpanel should be mounted securely to a wall or other stable surface. Use appropriate fasteners for the wall material. Make sure the subpanel is level and plumb. When connecting the wiring to the subpanel breakers, use the correct size and type of wire connectors. Tighten the connectors securely to prevent loose connections. Loose connections can cause overheating and fires. When running the wiring through the walls, use cable staples or other supports to secure the wiring. This will prevent the wiring from sagging or becoming damaged. Do not run wiring through sharp edges or abrasive surfaces. This can damage the insulation on the wiring and create a safety hazard. Protect the wiring with conduit or other protective materials. Make sure the wiring is properly supported and protected. When working with electrical panels, be aware of the danger of arc flash. Arc flash is a sudden release of electrical energy that can cause serious burns and other injuries. Wear appropriate personal protective equipment, or PPE, when working with electrical panels. PPE can include safety glasses, gloves, and arc-rated clothing. Be sure to adhere to the working clearance guidelines as required by the NEC. Working clearance provides room for electricians and other qualified people to work safely on or near energized electrical equipment. The depth of the working space depends on the voltage and condition of the equipment. Refer to NEC Table 110.26. Keep your work area clean and organized. This will help you to avoid accidents and make it easier to find the tools and materials you need. When you are finished working on the subpanel, double-check all your connections and make sure everything is properly installed. Turn the power back on and test the subpanel to make sure it is working properly. If you have any questions or concerns, consult a qualified electrician. The size of the grounding electrode conductor depends on the size of the ungrounded conductors. Refer to NEC Table 250.66 to determine the correct size of the grounding electrode conductor. The grounding electrode conductor should be connected to the grounding electrode system. The grounding electrode system can consist of ground rods, ground plates, or other approved grounding electrodes. The grounding electrode system should be installed in accordance with the NEC. The location and installation of the grounding electrode should meet the requirements of NEC Section 250.52. The resistance of the grounding electrode system should be as low as possible. The NEC requires that the resistance of a single grounding electrode not exceed 25 ohms. If the resistance exceeds 25 ohms, an additional grounding electrode is required. The two grounding electrodes need to be at least 6 feet apart. The bonding jumper between the main panel and the subpanel should be sized according to NEC Table 250.102. The bonding jumper should be installed in accordance with the NEC. The bonding jumper should be connected to the equipment grounding bus in both the main panel and the subpanel. The equipment grounding bus is connected to the metal enclosure of the panel. The equipment grounding conductor runs with the circuit conductors and connects the metal enclosures of electrical equipment to the equipment grounding bus. The equipment grounding conductor should be sized according to NEC Table 250.122. The equipment grounding conductor should be installed in accordance with the NEC. The equipment grounding conductor provides a low impedance path for fault current to return to the source. This helps to trip the breaker or fuse and clear the fault. The overcurrent protection devices, such as breakers and fuses, should be sized according to the NEC. The overcurrent protection devices should protect the wiring from overload and short circuit. The ampacity of the conductors should be equal to or greater than the rating of the overcurrent protection device. The overcurrent protection devices should be installed in accordance with the NEC. The working space around electrical equipment should be kept clear and unobstructed. The working space should be large enough to allow for safe and easy access to the equipment. The working space should be illuminated adequately. The working space should be protected from the weather. The location of the electrical equipment should be chosen carefully to minimize the risk of damage or injury. The electrical equipment should be installed in a dry location. The electrical equipment should be protected from physical damage. The electrical equipment should be accessible for maintenance and repair. The electrical equipment should be labeled clearly and accurately. The label should identify the purpose of the equipment and the voltage and current ratings. The label should be legible and durable. The electrical equipment should be inspected regularly for signs of damage or wear. Any damaged or worn equipment should be replaced immediately. The electrical equipment should be maintained in accordance with the manufacturer's instructions. The electrical equipment should be operated safely and responsibly. The electrical equipment should not be overloaded or misused. The electrical equipment should be protected from unauthorized access. The electrical equipment should be used only for its intended purpose. If you have any questions or concerns about electrical safety, consult a qualified electrician. Electrical safety is important for protecting yourself, your family, and your property. Always follow safe electrical practices. Always use qualified electricians. Always obtain the necessary permits. Always follow the NEC. The NEC is a comprehensive set of electrical safety standards. The NEC is updated every 3 years. The NEC is available from the National Fire Protection Association, or NFPA. The NFPA is a non-profit organization that develops and publishes codes and standards. The NFPA also provides training and education on fire safety and electrical safety. The NFPA website is www.nfpa.org. The NEC is a valuable resource for anyone working with electricity. The NEC can help you to avoid electrical hazards and ensure the safety of your electrical installations.